Langkah laksana dengan jitu, penuh bervisi guru ayu, mencapai misi yang satu, bervisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai. Mencari timba si anak dara di bawah sarang burung tempua. Selamat datang kami ucapkan. Selamat datang untuk semua. Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, salam Malaysia Banadi dan selamat petang buat semua penonton yang dikasihi di mana jua anda berada. Terutamanya kepada pelajar-pelajar yang sentiasa menunggu-nunggu siaran langsung kelas tuisyen online percuma bagi subjek Fizik SPM ini. Alhamdulillah hari ini kita dipertemukan semula pada 7 hari bulan Mei bersamaan dengan 15 Syawal. Jadi kita masih lagi di suasana raya ya Cikgu Yani.
Yes.
Jadi saya rasa tidak lambat lagi untuk saya mengucapkan selamat Hari Raya Aidilfitri, maaf zahir dan batin kepada semua guru-guru dan pelajar-pelajar yang beragama Islam. Okey, jadi sebelum kita mulakan kelas pada petang ini, marilah kita buka majlis dengan Ummul Kitab Al-Fatihah. Bagi yang bukan beragama Islam, anda boleh bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Okey, jadi sebelum kita mulakan kelas pada petang ini, izinkan cikgu perkenalkan dulu barisan guru-guru yang ada di konti pada petang ini. Okay, yang pertama kita ada Cikgu Peh di sana, nama sebenar beliau adalah Peh KH ataupun lebih dikenali sebagai Mr.Peh selaku presenter kita pada hari ini. Beliau kini bertugas di SMK Pusat Tingkatan 6 Tun Fatimah Melaka. Apa khabar Mr.Peh?
Khabar baik.
Okay, bagaimana cuaca di Melaka pada petang ini?
Cuaca hari ini okey lah, agak baik lah.
Baik cerah semua ceria. Okey, dan kita ada Cikgu Rosemawati di sana ataupun lebih dikenali sebagai Cikgu Yani dari SMK Bandar Bintulu Sarawak yang bertugas sebagai control host kita. Apa khabar Cikgu Yani?
Alhamdulillah baik hari ni. Cuaca pun baik.
Alhamdulillah. Bagaimana suasana raya di Bintulu?
Meriah ni, memang berayasakan je kerja dia.
Berayasakan.
Semua rumah nak dimasuk.
Kalau dekat sana dia glamour dengan kek lapis Sarawak
Betul, ya, kek lapis dengan air bergas.
Air bergas itu tak pernah tinggal. Okey, jadi dan saya sendiri Cikgu Hasnitah bertugas di SMK Bagan Jaya Batawat, bertindak sebagai moderator anda pada petang ini. Okey, jadi kelas ini kita akan bawakan lebih kurang dalam 1 jam dan akan disampaikan nanti dalam 2 bahasa iaitu kelas dalam DLP. Tajuk kita pada petang ini adalah 2.2 Linear Motion Graph. Okay. So, pelajar-pelajar yang bukan DLP juga boleh ikuti kelas ini. Okay. Jadi anda share lagi link kita kepada rakan-rakan yang lain. Mudah-mudahan ramai lagi yang dapat turut serta pada petang ini dan sama-sama kita dapat manfaat daripada apa yang bakal dikongsikan oleh Mr. Peh. Okay, cikgu juga nak ingatkan kepada pelajar-pelajar yang ingin memberi respon. Anda gunakanlah gambar profil yang bersesuaian dan sekiranya ada soalan anda boleh ajukan saja pada ruangan chat atau anda juga boleh kongsikan jawapan respon kepada soalan-soalan Mr. Peh nanti. Okey, baiklah, jadi cikgu tidak ingin membuang masa lagi, jadi presenter kita pun telah bersedia, pelajar-pelajar semua pun telah bersedia. Okay, sebelum itu anda boleh muat turun worksheet yang boleh yang ada dikongsikan oleh Mr. Peh. Ada ya Mr. Peh disediakan? Okey.
Ya, saya telah sediakan.
Okey, boleh, dan anda boleh muat turun dan cetak secara percuma sahaja. Okey, tidak ada bayaran apa-apa. Okey, jadi mari kita teruskan kelas petang ini. Silakan Mr. Peh.
Okay, so thank you Cikgu Hasnitah. Okay, so
Kita ada
seperti yang
soalan di sana Cikgu Peh.
oh,
Daripada Wei Min.
okay. Saya nampak okay. Okay, Wei Min yang worksheet
Dia
saya
tanya,
kamu just login dengan menggunakan MO email. Kamu akan terus dapat. Okay?
Anda
Gunakan
klik
MOE.
saja. Ya.
You klik saja dengan MOE email lah. Kamu gunakan personal email. Okay. Okay, so sebelum mulakan kelas, so cikgu nak beritahu lah semua. Okay, so kelas percuma AYU ini untuk kelas fizik kita ada 2. Di sini tingkatan 5. Diadakan pada hari Jumaat 9.30 malam. Minggu ini disampaikan oleh Cikgu Izyan. Okay, subtopik adalah 1.4 kekenyalan. So siapa yang tinggalkan kelas tersebut boleh pergi visit channel Cikgu Izyan. Dan untuk kelas tingkatan 4 kita adakan pada setiap hari Ahad seperti hari ini 3.30 petang. Okay, so ini merupakan panitia Fizik SPM Akademi Youtuber Malaysia. So hari ini ada bersama saya petang ini ada Cikgu Hasnitah dan Cikgu Izyan. Terima kasih bersama saya pada petang ini. Okay, so I am Mr.Peh. Currently I am teaching at KTE College tingkatan 6 Tun Fatimah Melaka. So the title for today will be subtopic from chapter 2, Force and Motion 1. The subtopic is linear motion graph. Okay, so in today's lesson, we have total about 5 learning standards. So the learning standard 1, you need to able interpret type of motion from the following graph. There are 3 type of the graph you need to understand. There is a displacement against time, velocity against time, and the last one will be acceleration against time. So let us see the type of motion from the graph. So the motion of the graph is very useful for interpreting the motion of an object. So we want to see the object whether it's in stationary, is moving in constant velocity, or accelerate, and also others condition. Okay, so basically we have 3 different type of the graph you need to understand. As I mentioned just now, firstly will be the displacement against time, sasaran lawan masa. The second type will be velocity against time, laju lawan masa, and the last one will be acceleration against time. Okay, so will be pejutan lawan masa. Okay, so basically from the graph you can get the information about the y-axis, x-axis, and the gradients of the graph together with the area under the graph. Okay, so the first type will be the displacement. So for the displacement against the time, the y-axis represent as a displacement. Okay, and then the x-axis will be time. Okay, and the gradients of the graph will be for this straight line, represent as the velocity. Okay, so y is velocity. So from here, you can see that the y-axis is displacements, and the x-axis will be time. Okay, so for gradients s over t, you will get velocity. Okay, so the gradients for the graph displacement against time represent as the velocity. And then there is no any information for the graph s against t, where the area under the graph. So that means you can only get velocity through the gradients of the graph s against t. Then for the second type of the graph, velocity against times will be y-axis will be represented as velocity lah. Okay, then the x-axis will be time. The gradients of the graph v against t represent as acceleration. Okay, so from here you see the y exists for this graph will be v, velocity, and then t will be s. So the gradients equal to v over t. That means y against x lah. For the mathematics you learn in P3 level already. So that means here it will be a. Okay, so actually you can get from substitution the unit. For velocity will be ms minus 1 divide s. So will become m per s square. So which is the unit for acceleration. Okay, and then the area under the graph will be represented as the displacement. Okay, so displacement for this area will be triangle. So 1 over 2 base times height. So the base will be time t lah, and then the height will be velocity. So if you substitute by using the unit meter per second for the velocity, then second for time. So you eliminate the s, you get finally left unit of meter, which is the unit for displacement or distance. Okay, so this is two information. So there are two information can be get through the graph v against t, which is acceleration by calculating the gradients, and then the displacement you need to calculate the area under the graph. Okay, and then the next will be regarding the graph acceleration against time. So will be like this now. So here the y-axis will be acceleration per jutan. Okay, and then the t will be x-axis. Okay, so there is no any information can you get from the graph acceleration against time. Okay, so both the gradients and area under the graph for the graph A against t not bring any information, not bring any meanings lah. Okay, so the next will be interpretation of the first side of the graph, displacement against the time. Okay, so basically there is 5 different shape of the graph and type of motion you can get from the graph displacement against time. Okay, so the first type of the motion will be stationary, not moving. Object tidak bergerak. Okay, so the object are at the same position. So you can see from here, if I say this is one of the value 10 meter. So at any period here, the distance is always the same, or the displacement is always the same. So that means the object is not moving, so that the position is always the same at any time. Okay, so you can also get the information from the gradients, which is represented as the velocity. So you can see that the gradients will be equal to 0. So that means no any velocity, the object is not moving. Then the second type of the graph, S against T, you can get will be like this shape. Okay, which is, you can see this is represented as the constant velocity, or you can know as uniform velocity also. Okay. Okay, so from here, you can see the gradients of the graph is positive. So positive because you can see the displacement is positive value is 20 here. And here will be a constant with a straight line here. So when this is a positive, that means the object is moving forward. For example, this is starting point with O. So the object is moving forward. So it will be positive. And here will be constant. You can see the graph. Okay, so the displacement increases constantly at every second. So the displacement will be increased with same distance at every period lah. And then the straight line of the graph has a constant gradients. So this is a straight line and it's constant. Okay, if let's say not constant, will be curved like this or like this. Okay, like this. Okay. Okay, so here we can get the information regarding the velocity, okay, where represent as the gradients of the graph. Okay, so here v equal to 20 divide 5, so we get 4. Okay, so the gradients of the graph, which is the velocity, equal to 4 meters per second. Okay, then third type of motion can be interpret to the graph s against t will be negative velocity. So you can see here the gradient is negative. So the gradient is positive will be increase like this. Okay, the gradient negative will be can be like this also lah. Okay, from this graph you can see the object is actually moving backward, go back to the same position. Okay, so the gradients of the graph is negative. So this is negative and constant. Constant because this is a straight line, which is decreasing, represented by this graph. Okay, so the object is moving to the left or backward. So that means just now initial is O, so it'll be moving at backward direction or left. Okay, so the object is returned back with the constant velocity to the left. So from here, you can see the object is moving from the final point to the initial point. Okay, and then the fourth type of the graph here will be uniform acceleration, or you can know as constant acceleration. So from here, you can see this is a curve. So this is a curved line, and we have two different gradients here. So here we have the P and Q. So from here, if you get the gradients, which is y over x, right? So here the y is smaller, and then the Q, the y is bigger. So that means that the gradients of the Q is greater than P. So the velocity increases. Okay, the gradients of the graph P is greater than at P. So Q is greater than P. So the gradient is positive. Okay, so it's at the positive. And the object moves with increasing velocity to right. So since this is a positive gradient, so the object moving at the right position or forward position. And here the gradients increases means the velocity of the object increases. Okay, so object moving with uniform acceleration. So increasing velocity means by uniform acceleration or constant acceleration. Okay, and then the last one will be uniform deceleration. So deceleration, that means that the object is moving with decreasing velocity. Okay, so here you can observe the gradients at P and Q again. So here the P, the gradients is greater than the Q. Again, you can get the formula y against y over x lah. Okay, so the gradients of the graph at Q is less than P. So here the gradient is still positive. So positive means the object is moving to forward or right. So object move with decreasing velocity because the gradients decreases. Okay, so decreasing velocity, that means will be uniform acceleration. Then the direction is still to the right due to the gradient is still positive. So basically this five different type of the motion of the object represented by the graph S against T. So here we can discuss one question regarding the motion, different motion of an object with this graph S against T here. So figure shows the displacement against time of the runner during warming up session. So explain and state the motion of the runner at the position of the graph at OP. So OP will be here, PQ will be here, RS will be here, and QR will be here, and RS will be here. So here, just now we already learned 5 different type of motion through the graph S against T. So here all is straight line. So that means here we do not have any acceleration or deceleration. So the first line here, OP, you can see this is a constant and positive. So that means this graph will be velocity, uniform velocity. Okay, and then PQ you can see is always at the same position. So it will be not moving. Okay, and then QR will be return back to the position. You can see the velocity at the distance, the distance will be 20 to 0. So it's go back. It decreases. Okay, that means here will be negative velocity. Okay, so we discuss one by one. So the first will be OP. So from OP, you can get the gradients, which is equal to 10. So 20 will be here. Divide 2. So you get 10. So you can write as the runner move with constant velocity of 10 meters per second to the right. Okay, this is a positive gradients now. Will be at right. Then the second will be PQ, will be here. So it's not moving. You can see it's always at the same position, 20 meters. So here will be stationary or not moving. So the gradients you can get is actually 0. Okay, so the explanation here will be the runner is not moving. Okay, and then the CQR will be here. So you can see here is return back to the position. Okay, so again, we can get the gradients will be negative 10. So the gradient is negative and constant. So the negative here represent or indicate that the object is moving at the opposite direction, which is at the, go back to the initial position. Okay, so here, the runner move with uniform velocity. Okay, so the velocity will be 10, but in the opposite direction with the magnitude of 10. The runner go back to his original position at the time t equal to 7. So you can see when t equal to 7, the displacement is 0. So that means go back to the initial or original position. Okay, so this is regarding CQR. Okay, and then the next will be the last one, RS, will be here. Okay, so the RS here, you can see the original position is 0. Then here will be negative 10. So that means here the object is moving at the left-hand side of the original position. And the velocity you may get through the gradients of the graph S against T here. Okay, so you can get the gradients of the graph is negative 10. Here will be 10. Here will be 1. So you get the velocity will be 10, but is in opposite direction. Okay, so the gradient is negative and constant. When the gradient is negative, they will be at the opposite position. So constant here, that means that the object is moving, the runner is moving at the uniform velocity with value of 10 meters per second, but is left from his original position. Okay, so that means that the runner will run from O to P and then stop at P. So P and Q will be at the same place. And then QR will be go back to original position when the T is equal to 7 here. Then another second 7 to 8 will be go to S. Okay, and OP will be 20 meter. Then QR will be 20 meter, so you can see here. Okay, and then RS will be 10 meter. Negative indicate that the position is left from his original position. Okay. Okay, then we go to the second type of motion, V against T. Okay, so again here, we have basically 5 different types of motion I'm going to discuss. The first one will be stationary. Object is not moving. Object itu tidak bergerak. Okay, you can see here, the V will be 0. Here you can see. Okay, so the gradients represent as acceleration. So here there is no any gradients. Like this, no gradients. Okay. Okay, and then the area, there is no any area under the graph for the graph V against T here. So that means no moving. Okay, no displacement. Okay. Okay, so that means we can conclude that the object is at rest condition. So the second type will be the constant velocity. So be the graph, the shape of the graph will be like this. Okay. Okay, so the gradients is still 0. Okay, so that means the acceleration is 0. So when 0 acceleration, if you already learned together with Cikgu Hasnitah last week, so the 0 acceleration is represented as the constant velocity. Okay, so the gradient 0, 0 acceleration, that means constant velocity. Okay, so the area under the graph will be here. So represent as the displacement. Okay, as per mentioned just now. Okay, so the area will be 10 times 2. So this is a rectangular. So it's equal to 20 meter. Okay, so the displacement travel will be 20 meter. And objects moving with uniform velocity, you can see the velocity is always the same where the value is 10. So uniform velocity is same meaning as the 0 acceleration. Okay, so the third graph here will be negative velocity. So you can see the velocity is at the negative value here. Okay, so here will be the gradients, which is equal to 0 here. Since this is always the same value, which is negative 10 here. So acceleration will be 0. And then here the displacement will be under the graph. So it will be negative 20. So negative 20, that means that the object is moving at the left-hand side or backward from its original position. So area under the graph is 20, negative. So the object is returned back with constant velocity to the left. Okay, so the velocity is always the same 10 meter per second, but the position is to the left. Okay, and then the fourth will be uniform acceleration or constant acceleration. So here, you can see this is a straight line, positive and constant. So here, this is a gradients. So the gradients represent acceleration. So here we have the value for the gradients. So that means the gradients will be, so that means there is the acceleration for this motion. So the gradient is positive and constant. Okay, positive will be this, negative will be this, go down. Okay, so as per mentioned just now, the gradients will be y 18 here against x here. So you get the unit will be meter per second square, which is acceleration. So the acceleration for this motion will be 6 meter per second square. Okay, and then another information you can get through the graph V against T will be displacement, which is area under the graph. Okay, so area under the graph will be 27. So how we get? So it will be this triangle. So triangle 1/2 base times height. Okay, so the base here will be 3. Height will be 18. So we get 27. So that means the object is moving 27 meter to the right from the original position with the acceleration of 6 meter per second square. Okay, so object move with constant increasing velocity or constant acceleration of 6 meter per second square. So the constant increasing velocity is same meanings as constant acceleration. So the last one will be uniform deceleration. So you can see the graph, the gradients will be negative, but here will be constant. Okay, so negative and constant. Okay, so the object with constant decreasing velocity. So initially we have the value of the velocity, and then here end up with 0. So that means the velocity is decreases. Okay, or in other words is constant deceleration. Okay, so the object is stopped where the v equal to 0. So that means here the velocity decreases and stop at the end. Okay. Okay, so here we go to checkpoint 2.2 question number 2 is a discussion regarding the graph v against t. Okay, so figure shows the velocity against time graph of a motorcycle along the straight route here. So explain the state of motion of the motorcycle represented by the position OA here, AB here, BC here, and CD here. Okay, so the OA, here you can see this is the positive and constant. So here means that we have the acceleration. And then AB will be moving with the same velocity, or known as a constant velocity. So the gradient is 0. That means the constant velocity is equivalent to 0 acceleration. Okay, and then BC will be here actually the B and C, although this is both showing negative of the graph, but BC showing that this is a decreasing velocity, where the value initial with the 25, final with 0. So that means the velocity is decreases. So here this is a deceleration motion. However, when going to CD, you can see the graph is at the negative position. So when moving with the negative motion, position here, that means that is at the opposite direction. So at C, the velocity is 0. And at D, the velocity is 10. So you can see here is actually increasing of velocity. So the increasing of velocity means that this is acceleration, but is at the opposite direction. So this is what you actually need to differentiate between the BC and CD. So I actually want to find this example for you because I want you to see the difference between BC and CD here. Both showing this is a negative gradients, but bring out the different information. Okay, so let us discuss detail for the graph. Okay, so for the first one, OA should be no any problem. So we get the gradients of the graph, which is represented as the acceleration. So we get the value is 2.5 meter per second square. Okay, so that means the motorcycle is moved with the constant acceleration 2.5 meter per second square. So this is a common question. Okay, no any problem. Okay, then the BAB, as I mentioned, you can see this is always the same velocity, which is 25 meter per second. So this will be constant or uniform velocity, okay, or 0 acceleration. So again, you can get the gradients will be 0. So the motion will be motorcycle move with constant velocity of 25.0 meter per second. Okay, and then the BC will be here as I mentioned, the initial velocity at point P will be 25 and C will be 0. So we are very clear that the velocity is decreases. So showing that there is a -5. So the negative here showing that this is the decreases of the velocity. But here is a positive value. So that means we'll be still moving at the right position. Okay. So the motorcycle moving with deceleration with the magnitude of 5 meters per second square, but stop at t equal to 20 here, we stop. Okay, and then the next will be the parts where I want to highlight today. So it will be CD. So here the gradients present negative, but here is actually accelerate, but moving at the opposite direction. Okay, so Jimmy, I hope that you can learn together and show your response if I say you don't understand. Okay, so the first one, we need to get the value of the gradients. So from here, we can see this is a negative gradients. Okay, this is a negative gradients. Okay, so here is a part where I want to highlight. In this case, even though the velocity of the motorcycle has an increasing magnitude, so as I mentioned, C, the V equal to 0. Then D, the velocity changes to -10 is actually 10. If I say we look at the magnitude. So here showing that this is an acceleration, but it's negative because the motorcycle is moving with the opposite direction. Okay, so the motion will be the motorcycle moving in the opposite direction on its back way with increasing velocity or uniform acceleration, which is equal to 20.0 meters per second square. Okay, so this is the parts where I want to highlight today for the graph of V against T, where the parts showing at the negative portion. Okay, so the last graph will be A against T. Okay, so for the A against T, just now we have already discussed 5 different types of the motion. Okay, so for here, the A against T cannot be showing any motion which is in stationary. Okay, and then the negative velocity also not able to show, okay, by the graph A against T. Okay, so for graph A against T, we can have 3 different types of motion, which is the first constant velocity. So as we discussed just now, the constant velocity represents as the 0 acceleration. So 0 acceleration, that means the value is at 0. You can look at the red color line here. Okay, so this is a 0 acceleration. Okay, so no info for the gradients and area under the graph from graph A against T. This one I show in the first slide already. So I just want to remind you again here. Okay, and then another 2 types of the graph will be the first, uniform acceleration. So be at the positive value. So object move with positive uniform acceleration. So the graph will be have positive value here. And then the next will be the uniform deceleration. So deceleration will be negative value. So object move with negative uniform acceleration or deceleration. So here we have two different information actually. Just now we mentioned uniform acceleration negative, that means accelerate but at the opposite direction. Deceleration here will be moving at the forward or right position, but the velocity is decreases. So both is different actually. Okay, so here this is summary of the shape of the linear motion graph. Okay, so here you can see just like I mentioned to you. Okay, so for stationary, we have only 2 graphs able to show S against T and B against T. So this is the shape of the graph. Okay, no any info can bring from graph A against T for stationary. Then for the constant velocity, S against T will be a straight line, constant and positive. So here will be gradients equal to 0, which is acceleration equal to 0. And then here, this is a value where the acceleration is 0, just like I showed you already. Then here, the negative velocity, gradient decreases for S against T. And then here, V against T will be always constant with a value negative. And A against T is not able to show the motion of negative velocity. Okay, and then the fourth one, this is the uniform acceleration. So you can see the graph S against T showing this is the increasing of the gradients. That means this will be the increasing of the velocity. So increasing velocity, that means there is a uniform acceleration. So with this. Then the last one will be the uniform deceleration. So here, the P and Q, just like I mentioned to you, the gradient showing decreases. That means this is a decreasing velocity. So the graph of the A against T will be negative. Okay, so this is a summary of these 5 different types of the shape of the linear motion of the graph. Okay, so Cikgu Hasnitah, I think we can take a break first.
Okay, very well. Baiklah pelajar-pelajar sekalian, kita berhenti rehat seketika. Jangan ke mana-mana, kembali lagi selepas ini.
Tuisyen online percuma. Tuisyen online percuma. Layari www.Akademi Youtuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma, mestilah Akademi Youtuber.
Okey, kepada yang baru saja sertai kelas kita pada petang ini, selamat datang kami ucapkan. Anda sedang mengikuti kelas tuition online secara percuma dibawakan oleh Akademi Youtuber Malaysia dengan kerjasama EDD Malaysia dan Kelab Guru Malaysia. Okey, kita sambung semula kelas kita dengan perbincangan yang seterusnya. Silakan Mr.Peh.
Okay, so thank you, Cikgu Hasnitah. Okay, so we go to second learning segment 2, so which is the analyze displacements time graph to determine the value of distance, displacement, and velocity. Okay, actually just now I also already show you how to get the distance, displacement, and velocity through the graph of displacement against time. So here I want to together discuss the fourth learning standard 2, learning standard 4, and the part 1, where is the conversion and sketching of the graph of the displacement against time graph to velocity against time graph. Okay, so I will discuss these 2 learning standards together with one example here. Okay, so it will be the example of question 3. Okay, so here the first one, the diagram show the displacement against time. So you can look at the axis S and Y here. Okay, and calculate the velocity of the car between these 4 different motion here. Okay, so as we mentioned just now, the velocity represented by the gradients of the graph for S against T. So that means this question actually is very easy. We just need to find the gradients of the graph. So the OP will be here. So it will be 20 divided 2. Okay, so we get 10. So 10 positive here is actually moving forward or to the right position with a constant velocity of 10 meters per second. But here, you just need to get the value. This is the extra information for the motion for the parts of OP here. Okay, and then the second will PQ. So the PQ and C is always at the same position where it's 20 here. So that means here will be always not moving here lah. Okay, so object will be not moving where the velocity will be 0. Okay, and then the third one, QR, will be here. Okay, so here you can see the object is moving from 20 back to 0. That means back to original position with the velocity of 10 meter per second. So the value of the velocity is negative 10 meter per second. So the motion will be moving backward with the constant velocity of 10 and reach initial point will be here at the t equal to 7 seconds. Then the fourth will be RS. So here you can see the displacement is actually at the backward or left of the original position. So it's negative 10. 10, here will be 1. So we get negative 10. So be backward or left from the initial position with the constant velocity of 10 meter per second. So that means object O move to P will be stopped at Q. P and Q is the same point actually. Okay. And then here will be back to O again. Okay, where show by point out. And then here will be S. Here will be 20. Here again, 20. You can see the difference. Here will be 10. Okay. Okay, so calculate the distance of the car in 8 seconds. So be until here. Okay, so this one I just now showed you already. OP is 20. So P will be stopped. And then PR will be back to original position, 0 here, right? And then go to the backward or left to S. So the total distance will be plus all together, we get 50 meters. Okay, and then the displacements will be, we want to get from the final and initial position. So here will be 20, here will be negative 20 because it's at the opposite direction. And then here will be negative 10. So we get negative 10 meters. So that means at the left-hand side from its original position. Okay, so here calculate the average speed. So the average speed you learn together with Cikgu Hasnitah already with the formula total distance over time second. So total distance will be 50. Time second will be 8. So we substitute to the formula. Okay, so the 50 as per mentioned will be get from B. So we get 6.25 meters per second. So your answer must be at least 2 decimal places with correct unit. Then the last will be average velocity. So formula, total displacement against time second. So the total displacement will be from C, which is negative 10. Divide time second 8. So we get negative 1.25 meters per second. Okay. Okay, and the next will be, we want to sketch, okay, the velocity against time graph from the graph of V against T. Okay, so we want to change S against T to V against T. Okay, so the tips here will be the gradients of the graph. S against T is the value of the V. So we already get the V value just now. So the first we get 10, right? Then second here is 0. Then the next two will be negative 10 also. We get from A already just now. Okay, so we want to draw the graph V against T. So first step, you have to label your y and x-axis with correct union symbol. So with this now. Here, v against, sorry, here will be t. Here is wrong already. V against t. Okay, and then second, you have to give the correct skew. So here we want the positive value, maximum is 10. Here we want the value is negative 10. So here time will be 2 until 8. Okay, so V is 10 and negative 10. So when we already get the value, the first 10 will be here until t equal to 2. So will be here. And then the second will be V equal to 0, 2 to 5 second here. So you can see from here to 5. Okay, and then the next, here negative 10, from 5 to 7. So from here to here. So will be here. Okay, and then the last will be 7 to 8, will be also negative 10. Actually, you can straight away draw from here to here. Okay, so this is how you change your convert graph S against T to V against T here. Okay, so I hope that you clear how to do the graph here. And then the next, we go to learning standard 3. We have to analyze the graph V against T to determine the value of distance, displacement, velocity, and acceleration. Okay, as per mentioned just now, the area under the graph of V against T, you may get distance or displacement. And then the gradients will be represented as the acceleration. And then the velocity you may get from the value started at axis Y. Another one will be learning standard 4, part 2, which is converting and sketching the graph V against T to A against T. Okay, just now the learning standard 4, part 1 will be converting or sketching the graph from S against T to V against T. So now it's from V against T to A against T. So I also using one example here. So question number 4. Okay, so this is a graph. The diagram shows the velocity against time graph of a car moving with 6 seconds. So until here, maximum is 6. So describe the motion of a car in first 6 seconds. So we need to discuss every line here. Okay, so the answer, we need to explain A, B. So the AB, you can see this is a straight line, positive, constant. So that means here we have the constant acceleration with the value of gradients here. 20 divide 2. So the A will be 10 meter per second squared. Okay, and then the BC will be decelerate. Okay, decelerate. Why? Because the B point, the V is equal to 30. And then the C, the V is 0. So deceleration. The velocity decreases. And then from C to D, although this one showing this is a negative gradients, but you can see the velocity V at the C is 0, but the V at D is 30. So that means this is accelerate. The negative value indicate the motion is at the opposite direction. Okay. Okay, so the first at 0 to second, so the car is moving in constant acceleration. You may give the value also of 10 meter per second square. Okay, but at least you need to give constant acceleration. If I say you don't give the value. Okay, and then the T from 2 to 4, this is the constant deceleration. So of the value. So here will be 30. Here is 2. So 30 divide 2. negative 15 per second square. So value will be 15 meter per second square. Okay, you showing deceleration, you don't need to give the value negative. You don't need to give the sign of negative. Okay, and then the last one here, the object is actually accelerate. Okay, accelerate here will be 15. Accelerate with 15 also, but it's in opposite direction. Okay, so the car move with constant acceleration of 15 meter per second square, but is in opposite direction. Okay, I hope that you're very clear how to differentiate the motion of BC and CD here. Okay, and then the next will be calculate the acceleration at AB. Okay, I already count just now. Okay, so the first one, okay, so here is the formula lah, where actually you should understand already. I explained just now, the gradients of the graph of V against T will be acceleration. So we need to find the gradients of the graph here. Okay, so the AB will be 30 minus 10. Then here will be 2 minus 0, so we get 10. Then BC, here will be 30 and 0, right? So 0 minus 30, 4 minus 2. So here we get negative lah, because you can see the graph is decreases. Okay, and then the next will be the CD. So CD will be here. Okay, so it will be negative 30 minus 0, 6 minus 4. So we get negative 15 also. So these two must be the same value, because this is, you can see this is a line BC and CD is joined together. So the gradients should be the same.
Mr. Peh,
Yeah.
ada sikit typo lah. Itu typo kod unit acceleration. Kita betulkan sikit lah.
Okay.
Yes. Okay.
Yeah. Thank you, Cikgu Hasnitah, for
Alright,
the correction.
thank you.
Okay, so this is the acceleration. So this is the error. Okay, if -1 is velocity. So this is
Velocity, yes.
acceleration. Okay, thank you, Cikgu Hasnitah.
Okay, no problem.
Okay, so the next will be calculate the distance and displacement after 6 seconds. So will be here. Just now we mentioned the area under the graph represent as the distance and displacement for graph V against T. So here, the first one, the area under the graph V against T is equal to distance or displacement. This one you know already. Okay, so here you can see we have two different parts here. Part A showing that the distance is moving at the original position. So that means it's to right position. So it's showing positive. So when the distance travel with opposite direction, so it will be negative. Okay, so here the total distance travel. So we just want to know the distance, so we need to add on A and B. The direction is not important for the distance, because the distance is a scalar quantity. So we just need to get the value. Okay, no any direction. But for the displacement, we need to get the initial and the final position. So that means we need to minus out A and B. We just want the shorter path between the initial position and the final position. So this is what I want to highlight here. Okay? Okay, so for the question number C, so that means we need to find out the area A, B, and C here. Okay, so you need to add on these three areas. So here the first one will be trapezium. So 1/2 A plus B times height. So we get this. Then B will be triangle. 1/2 height will be 30. Base will be 2. Then the last will be C. The height is 30. Then the base is 2. So we get 100 meter. Okay. Okay, then the D displacement, they will be what's the difference here? So as per mentioned, will be positive minus the negative part, which is the opposite direction. So you need to get this one, A plus B minus C. Okay, so again, the A will be this area, will be trapezium, will be same as what we calculate by using trapezium. Okay, so you'll get this one. Okay, and then the B will be area of triangle here. Again, it will be the same. Just the difference here will be the sign. Negative here. So we need to minus area of C here. So we get 40 meters. Okay, so I hope that you are able to follow the lesson, okay, because 1 hour want to cover what I want to bring to you is actually not enough. Okay, so I hope you all can manage to answer and understand. And then the next will be the average speed. Okay, so here we very straightforward. We already learned just now, and also together with Cikgu Hasnitah at section 2.1. So we with this formula, total distance divide time. Okay, so the total distance just now we get from C will be 100, right? Just now we just do, okay, and then divide with the total time taken will be 6. So we get 16.67 meters per second. So this one will be 2 decimal places with the correct unit for your answer. Huh? I already highlighted so many times. Okay, and then the F will be the average velocity. So average velocity will be using total displacement against time. So total displacement we get from D is 40. And the time taken will be same, 6. Then we get 6.67 meters per second. Okay, so this is the information you want to able to get through the graph V against T for learning standard 3. Okay, and then the last is for learning standard 4, part 2, which is you need to convert the graph V against T to graph A against T. Okay, sketch here got need to correction. Sketch lakarkan graph pecutan against masa bagi objek itu. So here also need to do correction. Sketch acceleration against time graph for the object. So we want to convert from the graph V against T to graph A against T. So again, how we get A is from the gradients of the graph V against T. So that means we need to find gradients of AB, BC, and CD. Okay, so we already get the value just now at A already. So where the V is equal to 10, here is for this graph, this gradients. And then BC 15, CD is also 15. So you can see here, this is a straight line. So both BC and CD showing the same gradients. Okay. So again, so first you need to give labeling for X and Y with correct symbol and unit. So here the symbol will be A, unit will be meter per second square for Y axis. Okay, so here also correction. T symbol for time, second for unit. Then second, you need to use the correct scale. So here we have positive value 10, negative value negative 15 for axis Y. Then for X will be 2, 4, and 8. We just follow what is the point we need. Okay, will be this for X, this for Y. Then for the first is 10. 10 will be here until 2. So will be here. Okay, and then the BC 15 negative between 2 to 4. 2 to 4 will be here. 15. Okay, and then the last one here, negative 15 also will be here. Okay, this is the answer. Yeah. Okay, then the last will be solve problem involving linear motion graph. Actually, it's the same with the just one now. Okay, I just simply pick one of the partial question. Okay, so this is a question of Putrajaya Trial 2022, question number 3. So it'll be 6 mark. Okay, so diagrams show the displacements against time graph of a moving object. What is means by the velocity? Okay, so when s against t, so the velocity represented by the gradients lah. Right? Okay, so here is the definition. Definition also learned together with Cikgu Hasnitah at section 2.1 already. So be rate change of displacement lah. Okay, so this is the answer. And then B, calculate the velocity of the object in the initial period 3 seconds. So here, initial 3 seconds will be here. So you need to find the gradients of AB. Okay, so how to get the value of A gradients for AB here? Okay, if I say you able to get your answer, you can just show at the chat room. Okay, this one is very easy actually. So that means you need to get Y, where is 10 right? And then your X is 3. Okay, so it will be 3.33 meter per second. Okay, 1 mark for substitution. Second mark for the answer with minimum decimal places. 2 decimal places we correct unit. Okay, and then see how long the object is stationary. Okay, so where is the position showing that the object is stationary? So for X against T, the position is always the same, where showing by 10 meter here. So that means B and C will be at the same position. So we stop. Okay, so here will be 10 with 3. Okay, so the answer will be 10 minus 3. So we get 7. Okay. And then the last, calculate the average velocity. So for average velocity, formula, total displacements divide total time. Okay, so here the total displacements, you can see initial 0, final 0 also. So that means the displacements will be 0 here. Okay, so will be 10 plus 0. 10 will be here. 0 will be BC. And then CD will be negative 10. Negative 10, Okay. Okay, negative 10. So that means here is actually 0 lah. But you need to show a step here to get your first mark. Divide total time second is 15. So final, you get 0 lah. Okay, so this is what I want to show today's, okay, for you. Okay, so that's all for my presentation. Okay, so that's all. Okay, so I pass back to moderator.
Okey. Okey, baik. Terima kasih Mr. Peh di atas perbincangan yang begitu jelas dengan contoh-contoh yang berkaitan itu tadi. Jadi diharap pelajar-pelajar yang mengikuti kita pada petang ini, anda dapatlah manfaatkan apa yang dibincangkan oleh Mr. Peh tadi, dan anda boleh tonton semula video ini untuk mendapatkan kesemua jawapan penuh bagi nota yang dikongsikan oleh Mr. Peh. Jangan lupa anda boleh muat turun nota berkenaan pada link yang disediakan dengan menggunakan email MOE anda. Okey, jadi sebelum saya akhiri, saya ingin persilakan dulu rakan-rakan saya untuk memberikan sepatah dua kata kepada penonton kita. Cikgu Yani, silakan. Mic tak buka Cikgu Yani. Okey.
Okay, terima kasih kepada semua pelajar yang setia bersama kita daripada awal kita bersiaran tadi sehingga sekarang. Dan kalau kat sekolah Cikgu Peh dengan Cikgu Has dah start ujian ke?
Kami 23 ni start, 23 Mei.
Oh, kalau sekolah saya esok dah start.
Oh, dah mula dah. Cepat ya.
Kalau ada student cikgu yang bersama kita sekarang, selamat mengulang kaji dan semoga berjaya untuk ujian esok hari ya.
Betul.
Okay, next kita berikan kepada Cikgu Hasnitah semula.
Okey, terima kasih Cikgu Yani. Mr.Peh ada sedikit kata-kata untuk sedikit pesanan petang ini, silakan.
Okay, so harap semua pelajar seperti Cikgu Yani sebutkan akan ada exam, so semualah boleh bersedia. Okay, so dan sentiasa mengikuti kelas kita. Okay, so kita akan sediakan bahan-bahan yang berguna kepada anda untuk buat ulang kaji. Okay, so di sini pun saya ambil kesempatan mengucapkan selamat Hari Raya. Okay, untuk semua pelajar, cikgu ataupun ibu bapa yang beragama Islam. So selamat Hari Raya dan berharap semua sihat sejahtera. Okay, thank you.
Okay. Jadi sebelum kita akhiri kelas pada petang ini, kita ingin war-warkan dulu kelas kita pada minggu hadapan. Jangan lupa ikuti pada hari Jumaat bersama dengan Cikgu Rina. Tajuknya 2.1 tekanan bendalir. Okay, tajuk baru untuk tingkatan 5. Tajuk yang kedua Jumaat 9.30 malam. Okay, dan untuk kelas tingkatan 4, saya akan sambung dengan tajuk yang seterusnya 2.3 free fall motion pada hari Ahad pukul 3.30 petang. Jadi dapatkan semua maklumat jadual tuition online PERCUMA di portal Akademi Youtuber www.akademiyoutuber.com. Okay, mudah-mudahan semua kelas yang dibawakan ini membawa manfaat kepada semua. Jadi cikgu tinggalkan anda dengan 2 rangkap pantun. Okey, bunga seroja di atas para, jatuh ditimpa buah berangan. Andai kata tersilap bicara, kemaafan jua kami pohonkan. Dari Kedah ke Pekansari, berdisuasa di kota tinggi. Selesai sudah tugas diberi, insya-Allah di lain masa bersua lagi. Jadi segala yang baik itu daripada Allah SWT, segala yang kurang itu daripada kelemahan kami. Dan kita jumpa lagi di masa-masa yang akan datang. Assalamualaikum, selamat petang dan bye-bye semua.
Bye-bye.
Tuition online percuma. Tuition online percuma. Layari www.akademiyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi Youtuber. Rujuk jadual di laman sesawang www.akademiyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi Youtuber.
Dibawakan kepada